Hi guys, this is Rajat. So this is my first YouTube video and I'm starting this channel to solve some Leetcode problems. I'll take you through these problems, how I solved the experience, and there are gonna be some hiccups here and there. Let's solve it again and again till we come through the solution. And also, please excuse me if there's any hiccup with the video. This is the first video, so let's start. So the problem I'm going to solve here is the number of islands, Leetcode problem number 200. I'm going to solve it in Java. There you see it's a medium level problem, got good number of likes. So yeah, I usually don't consider a problem as medium, hard, or easy, because that's all how Leetcode does tag it. But everyone has their own set of difficulty levels, so I won't go deeper into that. So the problem says that given a 2D grid of map, ones which is land, zeros which is water, count the number of islands. An island is surrounded by water, which is like zeros, and is formed by connecting adjacent lands horizontally and vertically. Okay, you may assume all four edges of the grid are all surrounded by water. Okay, so an example, there's an example which you can see in the notepad as well. So okay, the output says there's one island. Okay, let's try to find the island here. All the ones which is land. Okay, I think this is one island. Yeah, that's it. So what about the example 2? So if I go into example 2 here, I see that it has 3 islands, right? So 3 islands, if I 1 1, it is like 3 zeros. What is it? 1 1 0 0 0, and this like 0 0 1 0 0, and all 0 0 0 double 1. Okay, so here if you see, this forms one island, this is an island, and this is an island. There are total of 3 islands here, right? Yeah, so just thinking of this problem, if you see, right, so like what all I can see is like how do we go about this? This is a 2D grid map, right? So how do we go about solving this problem? Maybe what all we can do is, if you just look closely, it's like 2D map, right? We might need to like go onto each vertex, right? Go into each vertex here and there, and then move in all directions, and it's just like a graph traversal. So that's what we are trying to do here. So if we go about that, right? So if the algorithm looks like if we go by on this one, or let's say or this 0, right? So you start with this 0 here that I'm moving my cursor on. Then you can go in this direction, up, right, left, and then down. So this is what I think we could do as a kind of a recursive approach in a BFS. So let me just start to code. Then let's get into more thinking. So it's like whenever we visit a node, we're going to flag it as 0, so that mark it as water, so that we don't go into that land again. We just wet it. So yeah, just throw a bucket full of water on that, the piece of land. So yeah, that's how you make it like mark it visited. Yeah. So let's get going. So I'll start with taking a islands 0, and then let's write simple 2 loops. Not much of a thing here. Grid.len. Okay. So what I'm trying to do here is basically I'm just trying to loop over every other element that is there, right? So that I can like go there, check if it's a land or a water, and then make decisions. So grid I, not LNG. It's like looping over all the columns. Check plus, right? So now before going into deeper details about the problem, so what I tend to do is like I do a template first. So let's say I'm looping over each element. What will I check for land, right? And then recursive call to traversal, right? And I'm trying to do is like I'm trying to basically update the graph here, the grid here. So yeah, return islands. Yeah. So now what I need is basically, sorry, I think this should be here. Yeah. Okay, this. Yeah. Yeah. Okay. So I think I need some recursive function here. So what I'll do is like I'll write something like I can name like BFS map. I don't know, might not be a very good name, but yeah. So grid I comma j. Yeah, that's what we are intending to call, as we are not wanting anything to get it return to us anything. So just the parameters. If map char grid. Sorry. I int j. Okay. What next? Check for land. I'll fill this with if grid of I j, that element equals to 1. Remember that it's a character, right? So if it is this, what you're going to do is, before you call map, you are going to, all right, count, right? So this is a count that we are maintaining for number of islands. Let's say if we even encounter just a single one, nothing more than that, just a single one. So just like if in this case, let's say this one, right? With just this one, it also contributes. So this is how it triggers, and this is how it starts to look more land. So to look for more land, and so okay. And now what we're going to do is, so we have a recursive solution. So in our recursive solution, there's nothing to return. And now, as we talked before, what we're going to do is we are going to travel in 4 directions. So let's say if I have a reference point of ij, so what I'm doing, like BFS. So first of all, before even doing that, we're going to actually, sorry, grid ij. So because we'll only come here at this point when we mark it out, when we find a land which is at 1. So what we're going to do is like we'll mark it as 0. Now we are actually spilling water on that land so that we don't visit that land again. Now let's say let's move on all 4 directions. So if a coordinate is like I comma j that we have, so moving on top, so I can like BFS underscore map grid, I'll pass on the grid, so I comma j, right? So what I can do is like I can copy this the 4 times because we are going to into 4 directions. I'm going to change the coordinates now. So going up is like changing the row. You are decreasing the row -1, the column remains same. Going down is 1 plus the row, and now it's like going left and then going right. There you go. Yeah, so you have your BFS, you have your additions for or counting of the islands. What else? Will this work? Let's just try run it. I'm not going to run it right now, but I'm just thinking like, will it work or not? Okay. I don't think it should work because there's no condition that would stop us, right? The BFS map. There has to be something, because when you go into all 4 directions, and here there are cases where you will go like when you're starting in the first, when you're starting it from the first element here, right? So when you're starting with the first element, it would definitely go out of bound, the index of the array. So we need a check here, it's like a simple if I is less than 0 or I is greater than grid dot length length, or j less than 0, because j can also decrease to less than 0, or j is greater than grid dot length. Yeah, but this will not be a grid, it will be grid I dot length, because we are measuring the jth part. So it's the columns that we are looking forward to here. So that's what we are going to do. So yeah, okay, because greater than equal to, because yeah, so it's like we are actually checking still that if we haven't reached to that end limit. just a condition, and or we'll also check if grid I j equals to what, 1 0. If grid ij equals to, if it is coming in, it's already 1. So yeah, if it is already 0, if it's already water, we won't go anywhere. We just going to say return. That's it. Yeah, so I think this should work if we don't have any syntax errors. I'm not sure about that. Let's see. Oh yeah, you see, there's something here. Okay. Balance. A lot of typos when I type. I'm sorry. Yeah. Come on. Yeah. It passed. Yay. Trying to submit now. I think I submitted already. Okay, it passed. Yeah. All right. So this is how, guys, you can actually go about writing this code. So what we did actually was nothing much, right? So it was just a simple BFS, right, where I'm going in all directions, and you can apply this principle in a lot many graph problems where you go into a lot of different directions all together at once, and then evaluate what is the best possible solution. So I think that's all for me. Thank you. If you enjoyed, if you liked, just hit like button, subscribe to my channel. Thank you.